Okay, so in order to draw Lewis structures, first we have to look and see what elements are available in the molecule. In this example, you've got carbon tetrafluoride, so that's CF4. So I want you to draw your Lewis dot diagrams for each one of the elements. So you have carbon, which has 4 valence electrons, and then you have 4 fluorine atoms, which each have 7 valence electrons. So there's 1, 2, 3, and 4 fluorines. Okay, so now let's count our total number of electrons. You've got 7 here on each fluorine, so that's a total of 28 from the fluorine, 29, 30, 31, 32 when you count the carbon. So that's 32 total valence electrons. Now we have to count how many of those 32 are unpaired. So on carbon, 1, 2, 3, 4, all 4 of them are unpaired, and then each fluorine has a 1 that is unpaired, so it's a total of 8 unpaired electrons. Now we know that in order to make a covalent bond, you have to pair 2 unpaired electrons. So if I divide your number of unpaired electrons by 2, that will tell us that we're going to make 4 bonds total within this molecule. Okay, so now we have to determine which of these 4 is the center atom. It is always going to be the least electronegative element unless hydrogen is in there. Hydrogen can never be in the middle. From our studies of periodic trends, we know fluorine is the most electronegative element, so that means carbon must be less electronegative in this case. And almost always it's written in order, where the central element comes first. So we'll put carbon in the middle, and we've got 4 fluorines to put around it. So we'll just start putting fluorines around this carbon. And notice that I'm connecting them with a line. Each line is representing a single bond, so that's 2 electrons being shared. You can imagine it as being this electron and this electron forming a bond, and then so on and so forth. This electron forms a bond with this one, this one, this with this one. Okay, so now we have to satisfy the octet rule for all of the atoms. We have to make sure that each one has 8 electrons around it. If you look at carbon, it's got 2 here because that's a bond, so that's 2 electrons being shared. 2, 4, 6, 8. So carbon has the 8 electrons it needs. Now we have to give each fluorine the electrons they need. This one's got 2, so let's give it number 3, number 4, number 5, 6, 7, and 8. You'll notice this fluorine has 6 unshared electrons, as each of the fluorines up here did. So we'll keep going around. This fluorine also needs 6 then, as does this one, and as does this one. Okay, so to check your work, make sure each electron has, or each atom rather, has 8 electrons, and check to make sure you've used exactly 4 bonds as we predicted, and that we've used a total of 32 electrons. If you have 32 available, you have to use all of them, and you cannot use more than that. So there's 2, 4, 6, 8 are here, 8 here, 8 here, 8 here. 8 times 4 is 32, so you know you've done it right. So now let's go over to carbon dioxide. Again, we'll start by drawing the dot diagrams for each one. Carbon has 4 valence electrons. Oxygen has 6. 1, 2, 3, 4, 5, 6. And then the other oxygen also has 6. Okay, so that's 4 plus 6 is 16 total valence electrons. Out of those 16, it looks like 1, 2, 3, 4, 5, 6, 7, 8 are unpaired. Again, 2 of these unpaired ones make a bond, so we'll divide this by 2 and figure out that we're going to have 4 bonds. Okay, so again, carbon comes first. It's less electronegative, so we'll put it in the center. Let's put an oxygen on each side of carbon. But now we have a problem because we've only placed 2 bonds, but we said we have to place 4. This is where you begin using double or triple bonds. As a rule of thumb, let's try to make it symmetrical. So I'll put a bond here, forming a double bond on each side. Now you have to understand each bond represents 2 electrons. So this is 4 electrons being shared here and 4 electrons being shared here. Now let's satisfy the octet rule. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. So he is satisfied by the octet rule. This oxygen only has 1, 2, 3, 4. So we need to give it 4 more in the form of unshared electrons. And same with this oxygen over here. Now everybody has 8. So let's see how many total we've used. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which is how many we had available. So we know that we have done this correctly.